All right, so in terms of your assignment, these are the questions you're going to discuss. There's some questions down here. We'll talk about them. Let's give you some background. So this is all stuff we discussed at the beginning of class. The how are SOA components incorporated in enterprise systems? The artifacts of our enterprise databases, code classes, POI terminals are packaged up in boxes called Java classes. Now, if it's something like a database, we make what's called a mediator class. We write a Java class which is in charge of sending SQL statements to the data store and getting the results set back. So we model the operation of the database in UML by making a UML object called the database, and then we write methods in that Java class, and that Java class is what maintains the connection with the database, and we use the database by sending we call methods on the mediator class, which using the database connection technology that's appropriate, it actually dispatches the SQL to the data store and it gets the results set back. Now, I don't think in your Java class you actually worked with programmatically manipulating a SQL store, because I asked students in another class and they said no. I will teach you that, not today, but next week I'll teach you how we can manipulate a SQL or a Mongo database using program code, because if you don't have a feeling of how that works, you're not really going to understand how you can model a database using UML. For right now, I'm telling you, just draw a box on your diagram and then just say this is my database and create some methods, say write SQL statement, and it's the nature of doing doing SQL calls in a program language. If you send a SQL statement to a database, that method will have a result set. It'll have a return value, which is the result set that gives you back a collection object, and then you walk over it. You don't need to get into implementation in this lab, though. I'm just telling you that's how it works. All right, we've got about 15 minutes here. So we create service availability, advertising, and discovery mechanisms. That is your catalog, the enterprise catalog. To allow service providers or producers and consumers to automatically discover and connect together. And that is the basis of what makes an SOA architecture, and that is why you need the ability to change your business processes dynamically at runtime, just to make that work. In this way, our architecture can be dynamic. It can flow like water to accommodate real-time changes, unlike the old days of the code-oriented architecture in which we say things were poured in cement. Code was poured in cement. So here's what you have to turn in for your assignment. Here's what you're going to do with your lab. You're going to answer some questions. And you're going to provide it in the form of a Word document. I think Word is the easiest way. So it should have a title, and you can work in teams. Yep, so people have asked, can I work in teams? Yes, sure. Just provide everybody's information. And yeah, so student name, student ID, and all that stuff. Yep, so, and I will create an FOL Dropbox to put it in. It's not hard, it's pretty simple. So describe one traditional or old school enterprise systems weakness and the way we can solve that using IT resources. So the old systems, we've talked about things like client server back in the 1950s. What were the weakness? It was very limited, right? It was poured in cement. If you wanted to change the kind of business processes that your service could deliver, You had to go and rewrite all the code in your controller. In an SOA architecture, you can just update the business process description in your model. And I know you don't know how to do that yet, but you know in general that you can change the business processes delivered by your system by changing configuration files, text files, not having to go and rewrite code. Code-oriented architecture versus the new way of service-oriented architecture, where the services are business processes and they are described in text files, which you can either change yourself or you can write code to change your text file content. And in that way, you change the business processes your system's delivering. I'm making a recording of this. You can listen to my recording and contemplate on it. What problems do architects face when attempting to design a software system architecture for an organization? Changes in business processes, changes in available hardware, changes in external conditions, right? You guys are too young to remember this, but I was around. I was on the teams that were dealing when the thing with 9/11 happened, when some planes crashed into this buildings in New York, and it was the worst problem in business continuity, services and business recovery anybody had ever seen. So what happens when you lose the network, when you lose the data, right? There was this thing in the US last month with this oil gas pipeline being hacked, and it was a ransomware attack. The ransomware erased all the data on the servers. Those are problems. How can we mitigate these problems? Think about all the stuff I've said and come up with an answer to that. It's your lab. Put your pedal to the metal, put your brain into the problem. Maybe things like fluidity and flexibility of service delivery, the ability to scale easily, to have backup servers online that can cut in automatically if needed, right? So think about it. Review possible levels of message communication. So here, we haven't gotten into the slides yet. It's up there on FOL. What they're talking about is over here. Now, I have actually talked about this concepts, right? So what they're talking about is slide 31 and slide 32 over here. So these are all concepts we've discussed. So you can go and read that. I will upload it when I upload the assignment. I'm going to check how we're doing for time. 12 minutes. But we've talked about all of these concepts. So message communication can be messed up if you lose the network, right? It can be a catastrophic mess up, or it can be something that might happen as a result of doing a system upgrade, right? Maybe you update to a new version of a database and you didn't test properly, so that database is not compatible with your existing legacy code. So I gave you, that's actually just a link to our slides as well. So heterogeneous means you have different technologies or different file formats. So the distribution techniques, you can go there and you can look at the slides, or you can just contemplate the stuff we've talked about. Just give me some damn answer. I'll give you the mark. Don't sweat it too much. Because some of these questions are perhaps a bit abstractly written, but I'm trying to use as an opportunity to train you to think in terms of the abstraction. So distribution is TCP/IP networking, and it is the ability to, remember we talked about the concept of message queuing. So read the slides and just give me your best answer. I promise I won't fail anybody if their answer is not exactly 100% correct, but I would like you to give you the ability to engage in this by yourself. If you have any questions, you can post them up in the Slack room as well. Consider a consumer electronics company that manufactures customizable personal computers or devices. So they're saying the company delivers to its customer new version of the products on a very frequent basis. So they might want to configure it as a gaming machine or something with super high-end RAM and CPU. So they're saying the personal computer a customer may have today is a different product than the same one 6 months ago. There's a constant reconfiguration of components. So develop a UML analysis of the customer's requirements for the system to let customers make frequent changes to their computer configuration to upgrade its functionality. Explain your design choices and describe the services that you're going to introduce in your SOA solution. Now that might seem very complicated, but what we like to do is make complicated things simple. So UML is just drawing pictures. Small children can draw pictures. I think you can draw pictures as well. And how are you going to draw these pictures? You can use PowerPoint, Visio. You can use an online web service called draw.io. If you have any questions, just post it over there in the Slack room and I'll go in. I have a video talking about how to use it. It's pretty simple. So you can just go there and say new diagram. You can save it. Now they have things like UML templates. In my opinion, that makes it more complicated than it needs to be. So you could draw your diagram here if you want, or you can just use Visio or PowerPoint. Now my preferred way, the way I like to do things, is to draw it on a piece of paper and take a picture of it with my phone and then just upload that picture and include the picture in the Word document. I think that's the best way to do it. Now with our remaining 10 minutes of time, I will do a little bit of drawing some pictures to help you get started on this. So remember our requirement is, and now I'm probably going to do it a bit more complicated than you're going to do it. You don't have to do what I'm doing, but I'm just going to try and show you how we can use UML, right? So we've basically gotten the user story, right? Somebody has given us the user story. We don't have use cases, but we probably can go directly from our user stories to our UML. So we're saying we have a company that manufactures product and they want to give their customers a portal, a POI, a point of interface terminal, to go and update an order that the customer wants to make. That's the way I would read that. How you choose to read it doesn't have to be the exact same thing, but basically we want our customers to be able to access some sort of a portal like a website. And let's see how we're going to do that. Now, the way I'm going to do this is by shining my camera down on my desk and draw some pictures. And it's 10:50, so we have enough time. I think it should just take a couple of minutes to do this. So I'm going to turn off my camera here, and I'm going to turn on OBS over here.
А в деревню заехал, коней напоить, вздумал деревню гурьбою делить. Эх, трай-ля-ля, трай-ля-ля, вздумал
So let me shine my camera down here.
А старая старуха сметлива была, дочку Маруську с собою вела. Эх, трай-ля-ля, трай-ля-ля, дочку Маруську с собою вела. А старый старик свою.
So guys, do not kind of get stressed, right? Normally, so you already have the description. I can't really split screen, but we kind of remember what the description is. So we start by drawing out all the assets that we know of our customer wants. So they've said that they have some sort of a configuration tool, right? It's probably a database, but they have a configuration for their computers. So we'll just make an artifact called computer configuration. And we also have something called a customer. Now, a customer could be an actor, but for the sake of this diagram, I'm going to model my customer as a POI. So that's my point of interface terminal. And over here somewhere I have a customer. That's the UML representation for a customer, the stick figure. And what the POI is, the nice thing about UML is we can be agnostic about implementation. So agnostic just means we don't have knowledge of it. Agnostic means without knowledge. We don't know of implementation. So whether this is going to be a web screen or an iPhone screen or something, don't really care too much at this point. And I know I also have my configuration, which is probably going to be implemented as a database, I think. So now you just ask yourself the question, what are all the things? And here we're doing something called UI prototyping. if we were actually doing this at work, we would give our client or our manager, our boss, whoever's making the request of us, a piece of paper, and we would ask them to draw out screens to draw on this paper what fields and controls they want the user to provide. So we just have to sort of guess this. Now, I don't want to go into too much specifics because then you're going to give me back exactly what I gave you, and that sort of takes away your learning. But imagine you at a web page, you're buying a computer from Amazon. What do you need to tell them? Probably your name, I don't know, maybe shipping address. And then the purpose of this is to provide input over to this configuration database over here. So what do we need to know about a computer? Well, do your own research, or maybe you already know CPU, RAM, video card, right? I'm drawing this out small, but you might draw it out as a complete HTML page. Video card, yeah, CPU, RAM, whatever else it needs. I'll leave it to you to fill that in. But they're specifying their configuration, then they're getting some sort of a control, like a submit button or something. And now, how exactly is our POI terminal communicating with our database? Our requirement doesn't ask us to model that. We're going to assume we're using JAX-RS and we have a TCP/IP connection. You can abstract away. So another tool we use here is called abstraction. So that means we focus on the parts of the problem we need to solve, and other stuff like how exactly the communication happens between the Java class and the database. We can defer that to implementation time because we're at design time right now. So design means we need to know what our POI terminal looks like, and we need to know what services our database is going to provide, but how exactly they communicate, that's going to happen later when we do our implementation. So here we're going to focus on the design time concerns, not the implementation time concerns. So what exactly is this going to have? Well, I'm going to model it as a SQL database. I think that's probably the most practical way to do it. So here I would need to have tables, right? I need to have a customer table, and I would need to have a product table, and I would need to have an orders table. And I'm going to assume I already have a customer record, right? So you can assume you have a customer record already. Maybe they visited your website before and they set themselves up. We had another use case that lets a customer create to register themselves here. And product, now that's all the computers we have. So we might have something like model number. And again, CPU, all the stuff you're asking about over here. RAM, video, kind of motherboard, all that stuff. And now we need to make an order, right? So this is what we need to make. So we need to collect the customer. Maybe we have a customer ID. So maybe we want to provide that over here. You see, this is a very fluid process. And if any of you have ever designed a complicated software architecture not using Agile, which is what I'm demonstrating here, you will understand that it's very pleasant because this lets you get a high-level overview, which you can also easily share with other people. You know, you can show it to the client before you start coding it and say, is this what you want? They say, no, I need something different here, and I need for my fulfillment center, the part of my company which actually puts the computer in the box and ships it UPS to the customer. We need different stuff here. Maybe they want like a UPS number or something. So you have all of those design decisions with your customers before you even write a single line of code, which is really nice. But anyway, so you're going to be designing your computer configuration database, meaning you're going to think about all the things you need to create a customer order, right? I think, because it didn't exactly say that in our requirement, but we have to be capable of using good technical imagination as software developers here. We have to sort of fill in the blanks a little bit. And it's 11:01, so the class is over. So I'm going to save this video and kick it out. But basically, this is going to be your deliverable. It's going to be your best attempt, and I promise you, if it's not exactly perfect, nobody will get mad at you. Just do your very best. But think about how you can capture, because that's what UML is, right? That's what unified process is, and that's what our design methodology here. It is capturing, whoops, my papers are blowing away. It is capturing our best understanding of how the system works, understanding we can always improve it and amp it up later on. So I'm going to end the meeting now. I'm going to kick out this video once it's available. If you have any questions, you can ask, but do your best. My suggestion would be don't worry and stress, right? Don't get nervous or something. Just do your very best to translate, and you can watch my stuff on UML as well, right? You are going to be getting questions about UML on your test because we've talked about it a fair number of times here. But I'm going to turn off my video. I guess I've recorded everything for now.
А в деревню заехал, коней напоить, вздумал деревню гурьбой удивить. Эх, трай-ля-ля, вздумал деревню гурьбой удивить. А старая старуха сметлива была, дочку Маруську с собою вела. Эх, трай-ля-ля, дочку Маруську с собою вела. А старый старик свое дело смекнул, старую старуху он локтем толкнул. Эх, трай-ля-ля,